How to find the missing side of a similar shape. Well, let's review a little bit. What are similar polygons or similar shapes? Similar polygons, they have the same shape, but they're different in size. So here's three examples of shapes. They have the same shape, but they're different sizes. Now, one thing that's really important is that the sides are proportional on similar polygons. Well, what does that mean? The sides are proportional. Well, it means they have the same ratio. So here we have three similar right triangles. They all have the same shape, and they are similar. And the way that we know that they're similar, if you look at their sides, the smallest one has a ratio of 3 to 4 when you're comparing these two sides. The ratio of the middle size right triangle is 6 to 8. Well, that simplifies to 3 to 4. It has the same ratio as the first triangle, and the largest right triangle has the same ratio as the first two. It's 12 to 16, and 12 to 16 simplifies to 3 to 4. So that's how we know that these three right triangles are similar. Now, here are two right triangles. Are they similar? Do they have the same ratio when you're looking at their sides? This one has a ratio of 6 to 18, which would be 1 to 3, would simplify to 1 to 3. The larger right triangle has a ratio of 12 to 16, which is 3 to 4 if you simplify it. They don't have the same ratio. Those are not similar triangles. So we can use proportions to figure out missing sides of similar triangles. It's real easy to do. So in this first example, the ratio of this triangle is 4 to 6, and it's equal to the ratio of the second triangle, which is x, to 15. Now we can solve that a couple of different ways. We can either use equivalent fractions or cross multiply. I'll cross multiply on this one. So 6 times x is 6x. 4 times 15 is 60. Now we have a nice easy one-step equation. So our missing side would be 10 meters. If we look at the next example, the ratio of this triangle is 40 to 45, and it has the same ratio as a triangle that's similar to it, 16 to x. Now, rather than cross multiply on this one, I think I'm going to use equivalent fractions. Now remember, on a proportion, you can simplify a fraction. So if I divide each of these by 5, I would get 8/9. And that makes it real easy to solve. 8 times what is 16? 8 times 2. So I do 9 times 2. That means our missing side would be 18 centimeters. Okay. Now this is pretty important. Remember, in the first couple examples I just did, I only labeled two sides. If all three sides are labeled, make sure you're comparing the same two sides. And you're not comparing, for example, using this number, and then this side and this side. That wouldn't be accurate. Okay, let's try a few more. So, the ratio of this larger triangle is 32 to 20. And the ratio of this triangle is 24 to x. Now I could cross multiply, but I think it'd be easier to see if we can use equivalent fractions on this one. Now if I simplify this and I see that 4 goes into each, 4 goes into there 8, 4 goes in here 5, I could use equivalent fractions. 8 times 3 is 24, 5 times 3 is 15. Our missing side right here would be 15 meters. Okay, another example. Well, the ratio of this triangle is 14 to 22. The ratio of this triangle is 35 to x. Again, I could cross multiply, but I'm going to see if I can use equivalent fractions. If I simplify this, and they're both even numbers, 2 goes in there 7, 2 goes in there 11, I notice that I could use equivalent fractions. 7 times 5 is 35, 11 times 5 is 55. Our missing side would be 55 centimeters. Now, these are similar rectangles, and they still have sides that are proportional. So we can actually calculate and find the missing side on these similar rectangles. So we have x to 30 has the same ratio as 8 to 12. I'm going to see if I can use equivalent fractions again. I'm going to simplify this because I see that 4 goes into each of those. And I could. 3 times 10 is 30. 2 times 10 is 20. Our missing side would be 20 meters. Okay, now here's one. These are similar triangles. One's just rotated. So I'm going to compare the ratio of this triangle is 20 to 15. Now be careful. So that top number was the larger side, was the base of this triangle. I'm going to use the base of this triangle. So 20 to 15 has the same ratio as 24 to x. And I can use equivalent fractions on this one as well. I could divide each one of these by 5. And then I can use equivalent fractions. 4 times 6 is 24. 3 times 6 is 18. Our missing side would be 18 meters. All right, one final example. Now this triangle here is actually rotated upside down. No worries, this is still easy to do. The ratio, we're going to take this first triangle, and the ratio of x to 27 is the same as, now, I'm thinking of this as the base. I'm going to think of this as the base. It's just rotated. So my base is down here. X to 27. So my base has to go down here. And my other number would be 14 to 18. So x to 27 is the same ratio as 14 to 18. Let's see if we can use equivalent fractions. Now I could cross multiply. I could do 27 times 14 equals 18x and then divide each side by 18. But I always like to see if I can use equivalent fractions. If you simplify 14 and 18, 2 goes into each, then you'll notice we could use equivalent fractions. 9 times 3 is 27. 7 times 3 would be 21. Our missing side then would be 21 meters. So that's how you can use proportions to find missing sides of similar shapes.